Hi everyone. I want to show you today how you can calculate some key descriptive statistics using Microsoft Excel. There are many programs that you can use to do statistical analysis, and SPSS is one of the main ones. But if you have Excel, and many people do have Excel, you can do a lot of work just with that. So I provided you with a data file called employeedata.xls, and if you launch it, what you'll see is this is just kind of a set of data records in which each record is an employee record. So we have an employee ID, we have the gender of the employee, male in this case, the birth date, the number of years of education, the job category, the salary, current salary, the beginning salary, and so forth. So we have this test data file, and this is the kind of data file that you might have when you're collecting and analyzing data. You'd probably, of course, have something more educationally related, but nevertheless there would be a set of numbers here that you'd want to process in some way. So let's suppose that we want to analyze the salary field and look at, among all of the employees in this company, the salaries, and take a look at the average salary, that is the mean salary, the median salary, which is the middle salary, and the mode. And we'll also look at the standard deviation. So I'll show you how you can calculate these things quite easily in Excel. Okay, let's first scroll down to the bottom here, and we'll just type in mean, median, mode, and standard deviation. Okay, so what we'll do is we'll calculate the mean value and put it in this cell right here. Now, to calculate a mean, you just put in an equal sign, and then type in the word average, and then a bracket, like that. And now we have to put in the range of all of the salary values. So let's scroll back up to the top here. We can see that this salary value started here, which is at F2. That's the coordinates of this particularly, the first salary value. And we'll go on through F3 and 4 and so forth, all the way down to here. The last salary value is F475. Okay, so we type in F2 colon F475, close bracket, and there we get the average salary. So it's all of these salaries added up and divided by the number of employees, and so we have $34,420. Okay, so that's the mean. The median is calculated using a very similar formula. Again, you type in equals. This time, instead of using the word average, you type in median. And again, we'll use F2 to F475. And we get a median value of 28,875. Now this tells us something interesting right away. This is the middle number. So 50% of the salaries are below 28,000 and 50% are above 28,875. Now you notice the mean is higher than the median. This means there's probably a couple of high salaries, something up in the $200,000 or $100,000 range, that's pulling the average value up higher. So in this case, actually, the mean might be the median might be a better representation of where the middle is in this range of salaries. Okay, let's try the mode. Again, very similar. Equals mode, open bracket, F2 colon F475, close bracket. So $37.50 is the most common salary in here, in this list. And then finally we have the standard deviation. And I'm going to show you how to calculate that, and then we'll talk a little bit more about what standard deviation really means. You put an equal sign, STDEV, and again the round bracket, F2 colon F475. And then we get this value as the standard deviation. Now let's talk just quickly about what the standard deviation represents. Let's go over here. I've just put some numbers here just for fun, and let's take a look at them. If we take a look at these 11 numbers here, and if we calculate the mean value, like so, M462 to M472, we get a mean value of 6. Now if we do the same thing over here, we get the same mean value. But the interesting thing here is that although we have the same mean value, the distribution of numbers is very different. Here we have some very low numbers and some very high numbers. They all center around an average of 6, but there's kind of a big spread of the numbers, going from 1 all the way to 11. In this set of numbers, the spread is fairly small. There's no number lower than 5 or higher than 6, higher than 7. So everything is between 5 and 7, yet the average is still 6. So that's what the standard deviation measures. It measures how much spread there is around the mean value. So if we calculate the standard deviation here, we get a standard deviation of 3.3, and if we calculate it over here, we get a much smaller standard deviation, 0.89. So this tells us that although the mean is 6, there's actually a very, the numbers are clustered very close to the number 6 in this distribution. Whereas here, the mean is 6, but the numbers are more spread out. And so these two numbers, the mean and the standard deviation, are often used when describing statistical distributions to give us a sense of both where the average number is in the distribution, but also how spread out the numbers are. Okay, so you've seen how to calculate the mean, the median, the mode, and the standard deviation for a set of numbers using Excel. So now try it yourself. Try loading in the employee data.xls file and try calculating those figures for, say, the salary beginning, and see what you get for those numbers. Okay, thanks.